Welcome back to the Savage Sullivan Math website. Today we're going to look at a different example of solving systems by substitution. When you look at our previous video, you'll see that both of our equations in our system that we solved by substitution already had a variable that was isolated, which is nice, but it's not always going to be the case. So we're going to look at two examples where you have to do an additional step of isolating a variable. When I look at this system, I see that the y has a coefficient of 1, meaning there's no other number that's attached to it. So that tells me that that is the variable that I want to isolate. So there's a couple of different ways you could rewrite this, but I'm going to go ahead and I'm going to start by rewriting this equation, and the first thing I'm going to do is I'm going to subtract 5x from both sides. And when I do that, I'm going to be left with negative y, don't lose that negative sign, equals 4 minus 5x. It's still not totally isolated because we want a positive coefficient. So we're going to divide everything by negative 1. And I'm going to have y equals 4 divided by negative 1 is negative 4. Negative 5 divided by negative 1 is a positive 5x. So now I have these two equations in my system that I can work with. And if you remember our video from yesterday, from here it's pretty simple. I'm going to take the negative 4 plus 5x and I'm going to substitute it in for the y in this equation here. So I'm going to have now 2x plus 2 times negative 4 plus 5x equals 16. And we're going to go ahead and solve that equation. So we're going to have 2x plus, when I distribute, negative 8 plus 10x equals 16. Combine your like terms. 2x plus 10x is 12x. And instead of writing it as plus negative 8, that's the same as just subtracting 8. Add the 8 to the 16. And we're going to have 12x equals, we got 24. Okay. Divide both sides by 12. Had a little mind blank there. And we're going to have x equals 2. Okay. Now we go back, and since we have these two equations, we no longer really have to worry about this top one. So I'm going to take this x, and I'm going to plug it in for the x up here. And we're going to have y equals negative 4 plus 5 times 2. Again, that 2 is replacing the x up top. So we have y equals negative 4 plus 10. Y equals 6, which means our point is 2, 6. Now, this one was a little trickier, so it is probably a good idea to do a check of your problem to make sure you didn't make a careless error or what we call a silly Sally. So over here, I'm going to do a check. And you can pick whichever pair that you want to plug into. So I'm going to plug in my 2 for my x, and I'm going to plug in the 6 for the y. And we're going to see if we get 16. And we're going to have 4 plus 12, that equals 16. So we know that it works in that first equation in our system. So we still have to check the other one, because remember, to be a solution, it has to work in both. So we're going to have 6 for the y and 2 for the x. And we'll see that 6 is negative 4 plus 10. So since it works in both equations, this is my solution point.
Here is another example. You notice on this example, none of the variables have a coefficient of 1. So you need to pick which variable you are going to solve for. And it technically doesn't matter. However, typically there's going to be one that will provide a little less headache, and it'll be a little bit easier because you won't be dealing with fractions. In this case, if I look at the bottom equation, 7 and 8 don't match up. Neither one is a factor of the other, so that one's not going to be a good choice. But 2 goes into 6 nicely. So I'm going to solve for this x. So if I take this equation over here, and I have the 2x minus 6y is equal to negative 6, and I'm going to solve for this x, that means I'm going to add 6y to both sides of the equation. I'm left with 2x is equal to 6y minus 6. Divide everything by 2, and now I have x is equal to 3y minus 3. Don't forget that we took this from the top equation. So now we know x is equal to this expression, so we need to replace the x in the bottom equation with that equivalent expression. So when I rewrite the bottom equation, instead of writing x, I'm going to write its equivalent expression. So now I have 7 times 3y minus 3 minus 8y is equal to 5. Do the distribution, you get 21y minus 21 minus 8y is equal to 5. When you combine your like terms of 21y and negative 8y, you are left with 13y. Minus 21 is equal to 5. Add 21 to both sides. You have 13y is equal to 26. Divide both sides by 13, and y is equal to 2. Now, we know that our final ordered pair is going to have y value of 2 in its final coordinate. So now we know that the y is 2, so we're going to take that value, plug it into this equation to get our x value. So x is equal to 3 times 2 minus 3. So 6 minus 3 is 3. That's our x value. So here is our answer. Again, always good to do a check. Sometimes when you have to do a lot of manipulation, it might be a good idea just to use both of the original equations to make sure that you did your manipulation correct in the first place. So I'm going to use both of my original equations. So 2 times 3 for x minus 6 times 2 for y is equal to negative 6. 6 minus 12 is equal to negative 6. Yes, we did it. Negative 6 is equal to negative 6. Second equation, 7 times 3 for x minus 8 times 2 for y is equal to 5. So 21 minus 16 is equal to 5. 5 equals 5. Again, hooray! We've done it. We found our correct solution. If you enjoyed this video, please like and subscribe.